It's your boy, the Canologist, and we're back. We're gonna be doing another Leetcode AFK session. As you can see, I have this fancy ass gear over here where I have Nezi helm, Zamorak, blessed Zamorak body, Zamorak DI boots, dragon plate. I got a regen, archers, odium, a bunch of bone bolts. These are really cheap. If I examine them, I'm just gonna show you. Good, you have a crossbow, and then Dargeshan, bone cross, and then Ava's attractor. These cost like 2 GP a piece, so they're like super cheap. Range defense bonus. Good defense is here, range is plus, and then 53 range strength, 2.4 attack speed, so it attacks just as fast as a skimmy. So if you don't already know, that is the best. Okay, so we got these three: Trap Soul, Can Drainer, Sand Snaking, Rolled Candle, Accept. Alright, let's move this shit down here. So I'm not going to use it. And then let's go there. I'm going to take 3 doses. Make sure your auto retaliate is on, which mine is. And then basically I'm going to get my pommel focus timer once this thing starts. So let's see. Where's the first guy? Where's the first guy? Where the fuck are you? Let's go. The first guy that walks towards me, kill the snake. Cool. And then we hit the timer, start pommel focus, and that is the start. So we're going to go to this Leetcode question called POW-XN. So basically, we want to implement POW-XN with calculus x raised to the power of n. Okay. What the fuck does that mean? So basically what we want to do is, what a power is basically is it's just a number times itself. So n, let's say n is equal to 3. Anything to the power of 0 equals 1. Anything from greater than 0, not greater than or equal to, anything greater than 0 now becomes x, the power of whatever. So 3 to the power of x. So let's go 3 to the power of x, anything greater than 0. So basically, if we got 3 to the power of 1, that's 3. 3 to the power of 2 is 3 times 3. 3 to the power of 3 is 3 times 3 times 3. 3 to the power of 4. And I'll show you guys why I'm doing this, because I just want to show you guys going up to n elements equals 3 times 3 times 3 times 3 all the way to 3 to the power of n equals 3 times x times 3. So that will be n times. So this is pretty much the essential concept of this question of powers. That's what we want to think about when we think about powers. So we're not talking about Austin Powers, by the way. Fucking golden member where that motherfucker ate his own skin flakes. Fuck that. Anyways, let's get back to it. Not that. I don't know why my Discord's open. Okay, anyways, let's look at this. Wait, why do I have VS Code open? Okay, there's so many tabs and shit. I have to keep making sure I check this to make sure that this doesn't freeze, because I'm using my fucking MacBook Air, alright? Don't judge me. One sec, let me see if I can change the song. Yo, I fucking hate this song. I don't mind this. I don't mind this. Oh, Gnome King. What's Gnome King? Gnome Village Party. Alright, I can vibe to this. I can vibe to this. Alright, anyways. Now we got the tunes. Now we got some focus music. Now we can concentrate on the goal here. The goal is to get to this. Okay, so the powers. Okay, let's select all this and delete it. Now that we know the concept of powers, just in case you guys aren't familiar with math, a lot of you guys come from an art background or something. I came from an electrical engineering background, and I swapped into this field of computer science. So I don't judge anyone here. I'm going to explain things from scratch. And we're going to play RuneScape because we fucking love RuneScape. Look at these biceps. Anyways, back to the question. Yeah, implement the power, for example, this to the power of n. And this looks like it's a floating point. So this is 1 over to the power 2. N is an integer, and either x is not 0 or... Oh, it's not 0 or... So we're never going to have a power of 0. I mean, we could still plan for it. We could just say if x equals 0, then just make it return 1. Because as we already covered in this test, I'm just curious now. I'm just curious. Like, is there ever going to be a situation where there's 0? It's looking for a float output, so I have to do this. If x is 0.0, are we doing integers? As yeah, n is an integer. N is the power, which is an integer. X is the float. So if x is 0.0, no, if x is 0, then you just get 1.0. Let's try that. Basically, not valid, expect for return type double. A double. This is all floating points. I don't know why this is not working. It should be 1. Oh, because it's not a... Okay, so I could do this. Either way, let's just keep running it because I don't have a direct return. Maybe it's because it never actually hits 0, like it says here. Okay, n is an integer. Okay, cool. We're good with that. Constraints: x can be between negative 100.0 and 100.0, which is fine. May it never get to this. Okay, so then. Now we want to kind of tackle the next part of the question. So we want to do when x is to the power of n and when x is to the power of negative n. Okay, so when x is to the power of negative n. So we want to have some sort of check. If what do I want to do? Okay, let's just do this. We'll do an O of n. So 4. Or no, let's do a while loop. Let's do a while loop. While. And then let's call this counter. Let's make it a 1 slot counter, while counter. I want to go result. We can make that x, or we could just keep multiplying x. See, that's the thing. What do I want to do? I could do temp. I don't want to call it result because it's not a result, it's a temp. So I can take x. And then I can go temp. Times equals x. So it's just going to be itself times 1. Or if it's 1, I'm curious. Power of -1. That should be 1 over 10 or something. 1 over the value. Yeah. It should be 1 over the value. So whatever that is, if it's negative, it should be 1 over that value. So then I'm gonna say if, how do I want to do this? Temp counter, and then if it's less than 1, if x is less than 1 or 0, so that way if it's negative, just make it 1 over the value. If it's 1 on its own, I could just do a bunch of edge cases. I'm just curious. Okay, let's just do it that way. I don't want to overstrain my brain. So temp times x, and then I want to go counter plus equals 1. So that way it doesn't go past the loop and go infinitely. Then if counter is less than, oh no, not counter, if n, which is the integer value, is less than 0, then I want to go beneath. So that means I want to go 1 over. So temp equals 1 over temp. Then I want to return temp. So basically if it's 1, what do I want to do? Oh, I could just make it 1. There. So then if it's 1, which it is, then I times it, and it's itself. And then if it's 1 over that, 1 divided by itself. Then 2, then it's times x, then it's times x, then it's times x. So that should be it. Let's try it. Case 3, why does this fail? Okay, let's look at case 1. X equals 10. $1,024 as expected. Okay, cool. 2.1 times 3 as expected times 2. 1 temp equals 1 divided by temp. N equals -2. Okay, so this should trigger this. Temp is now equal to 1 divided by temp. But it's 1.0. Oh, because it's floating pointed. So let's try that. I'm just curious. It should just be 1 divided by this. Okay, I could do an if else. I can try that. I can try an if else. I'm just really confused as to why this doesn't work. The result will always be a float. Okay, so that means it should work, technically. It should work, technically. So I'm just, okay, wait, let me just make sure that this resets. Let's finish it. Why doesn't this work? So I want to confirm why that doesn't work. It's less than 0, which means it's negative. N is a negative value. What if I do this? Because this should be to the power of 2, and then 1 is divided by 4. So basically, if x is 2, n is -2, 2 to the power of 2 is 4, 1 divided by 4 is 0.25. So why doesn't this work? N less than 0 is n if n is less than 0. Oh, I can just return it as is. What if I do that? Why doesn't that work? That should technically work as well. It should get into this block. If x equals 0, what if I delete this? I'm curious now. Maybe this loop is messing it up. Okay. Still no answer. While counter is less than n, while counter is less than n. N is less than 0. Ah, I see why. I see why, because when it's negative. Okay, so let's go absolute value of n. Because when it's less than 0, it's going to keep being less than 0. So it's never going to make it through this loop if it's negative values. So we have to take the positive value of n, and then when we get to here, we have to check the actual value of n. This should fix it. Okay. And then we can submit that. Okay, time limit exceeded. Why did it exceed? Okay, so this solution technically works. It's just that when you get to an end that's super large, it's looping so many times when it doesn't have to. So what do I want to do? Which is raise the power of n. You could use the shift register method technically if we're going by powers. Like the bitwise shift register, if I convert this to binary, but that is a working solution here. Like for example, if we ChatGPT this, it's gonna say it's correct. Without correcting or suggesting anything better. Does my code emulate the POW function in Python? Yes, your code emulates the thing, it correctly handles this. Doesn't handle edge cases like 0, 0, but it works. For the purposes of the challenge, it was mentioned 0 case wouldn't be presented. So is this perfect otherwise? Yes, gives the 0 base one thing, code perfectly emulates, logically works. So this is a valid solution, guys. Like, you can do this, but now, like, if you're in an interview, they're gonna be like, can you optimize this? So let's look at ways we can optimize this together, because we're all in the same fucking boat here. All right, I'm learning this shit. I've done 100 of these, but like once you stop doing it for like a few months, like 2-3 months, you have to like get back into the mode of doing it again, which is why I can kind of explain the concepts to you, but like when it comes down to syntax and shit, I gotta look it up, because I'm using like 6 different languages day to day. I'm using like React, JavaScript, PHP, Laravel, SQL, I'm using Golang, I'm using, what else do I use? Just a bunch of shit, you know? Just a bunch. So like when you do all that, like it really comes down to concepts. So let's see how we can make this better. Python, how to implement powers in Python manually. Implementing the power function without using thing. Well, I could technically just do that, but that's built in, so that's cheating. Program to find power of a number. Using recursion. Half's number to reduce the operations. It's an elegant, but involves a function call stack. Increases the space complexity. Okay, so if x is 0, return 1, half power, and divided by 2. But it still uses power, so it's like, okay, so power n divided by 2. It doesn't handle the negative case. Using a loop, this is what I did. Okay, so let's work with ChatGPT then. So currently my solution works, but exceeds the time limit. How can I make this more efficient? Exponent by squaring, which reduces O of n to overlog of n. Recursively or iteratively half the square and half n. Result if n is greater than 0, else 1 divided by a result. Okay, so it basically just fits my condition in. What else does it do here? So this result is 1. Okay, that's fine. Power equals absolute value of n. Power percent 2 equals 1. So if we're doing odd, so that's an odd number, result times x. Okay, explain this code. I'm gonna write shit down on my notepad too. Okay, here's the breakdown of how efficient the myPal function works. So myPal equals self. S is a float. N is an int, which is the integer to the power of. So let's break this down on the whiteboard. N. So this is an int. This is a float. Okay, let's go through this next part. What do we want to do now? When integer is divided by x. Okay, cool. Float and int float. Okay, so result is 1. What do we have? We start with temp equals 1, so we can go result temp. So that's basically it. So it's the same. Power absolute n. I did absolute n as well, and then less than or equal to, and they do the same thing. Power absolute n. Okay, that's fine. While power is greater than 0. If the power is greater than 0, result times equals x. Okay. If the power is odd, multiply result by xy, because we can't divide power evenly. So we pull 1 out of the x. Okay. So instead of doing work on the result, we do work on the integer. So we can't divide evenly. Okay, so then x times x, if it's even. Square x, now x2, x4, half the power using integer division. This reduces the problem size by half each time. Okay, and then return the result. If n is greater than 0, else 1. If n is negative, then, okay. I think this part, okay, further explain this part. Why did they half it? Let's see why they half it. Is the core exponentiation by squaring. Here's what it does step by step. So power 2%, power percent 2 checks if the power is odd. Okay, yeah, that's fine. Because anything divided by 2 divides it by 2. Anything percent divided by 2 with the remainder of 1 means it's odd. Because if the power is even, we can't write power divided by 2. If the power is even, we can write 2. Oh, we can pull out x to the power of 2. And then half of it. So basically, if the power is even, I see what's happening now. So this is what's happening. It's like a math question kind of thing. So like, let's say we have x is 10. You're basically saying you can go x2. And then that now becomes 5, I guess, divided by 2. Or 10 divided by 2. Yeah. So x2, you can pull out 2, and then you have 10 divided by 2. So now you have x2, x5, I think. And I think that's what they're trying to get at. So what do we got? Let's go back here. Yeah, so this would be, one sec, let me get my eraser. This would be x2, this would be 10, and then now this would be power divided by 2. So x times x power minus 1. Power is odd, we can't cleanly half it, but we can break off 1. So now we can say, so 3 would be 2 minus 1, power minus 1, so 3 minus 1. Or x times 2 minus 1, so that's basically it. Example 2, n equals 5. So in summary, if the power is 2, handles it by using up 1, then we square and half the power to keep going. So this way we can kind of reduce the computations. I see what that's kind of doing. So basically what's happening here is this would be the same as saying, and I believe that's the case, x times 2 to the power of 5. And then you only have 5 computations instead of going times 2, times 2, times 2, times 2, times 2, or whatever the fuck that is. Now we do it times 5. Then if you have x to the power of 3, I think. Let's see it. So x3 would be x times 2 minus 1. Or times 3 minus 1. Yeah, it would be x power x3 equals x times x 3 minus 1. Times x3 minus 1 equals x times x squared. And that's the computation effect. And x squared is just x times x. And that just reduces the amount of computations, I think. When you have like x times 20,000, you want to reduce that. Okay, so I guess that's the way to go. So what do they have here? Result equals 1, power absolute n. Okay. While the power is greater than 0, get the value. So result times x. And then we go x times x. and then we half the power. Okay, so let's just do it with ChatGPT. So we have, I think x equals 1. Result equals 1. Okay, so instead of temp, they just use result, and then they do work on the result. So it's pretty much similar. Result equals 1. Then they have powers. They have powers. So result equals 1. And then they have some sort of power. Yeah, absolute value event. And they go while power, I think, is greater than 0. And then if power %2 equals 1. If it's an odd number, then we want to go result times equals, that would be n, I think, right? Or x. Result times equals x, because x is the value we're multiplying by, n is the amount of times. So, okay, and then we want to go the power of, so x times equals x. Because now we're pulling at a power, and then now we got to times it, only if it's like this. Otherwise, we just multiply it by itself, and then we just half it. So x equals, can you do it like this? I don't know if you can even do the syntax. Oh yeah, you can. Power divided by 2. So you floor it. You floor the power, you times x. Either way. And then when it's an odd number, you do it again. And then you say return. And then you basically do what we did. So you return the result. And then if is less than or equal to 0, how do you do ternary in Python? Can you just do it the normal way? Oh, you have to do an if-else statement. Okay, if else 1 divided by result. So result if greater than 0, else. So that's your ternary. 1 divided by result. What the hell? Maybe I'm missing something. So let's see if what I did wrong here. There's probably some syntax. Small mistake in this line. Oh, I might have had it backwards. So if result if n is greater than 0. Okay, so this is the ternary. I got that wrong. And then else, use the 1 divided by, because now it's a negative number. This should work. This is like the more efficient way to do what we did the first round, where we got it all correct, but the for loop just takes too long. So it's still kind of weird, but as long as you follow this concept of like the power, this concept right here. So if it's an even number, it's just x divided by 2, so it's x times x, and then half the power. X times x, and then half the power. Otherwise, you do an extra multiply for every odd number. So like, for example here, one more time we'll go x times x. You're going to do x times x regardless, no matter what. The only time you do an extra one is if it's an odd number. That's when you have to do x times x power 1. So if it's like 3, you pull out 1, now you get x to the power squared, and then you times that to get this portion. And you just keep halving the powers to reduce the computations. So yeah, that's pretty much it. See if I missed anything. Yeah, that should be it. So if you like this guy, please give it a thumbs up, subscribe, comment below. We're gonna keep doing these. This is my first 5 after a while, so once we get to like 100, 200 of these, we're gonna all be experts at this, and we're all gonna be like 99 stats. Look at this, it's almost done. But yeah, stay tuned. Canalgist out.